So now we want to develop a formal procedure for testing hypotheses. We have the framework of the null and alternative hypothesis. The null hypothesis is the status quo, what we currently believe about the world. The alternative hypothesis is the contender, the challenger, that we are testing for validity. We also understand the role of the statistician in setting the confidence level through a choice of alpha, the probability of rejecting a good null hypothesis. That is, we set the probability of making the mistake of overthrowing the whole status quo. Here is the systematic approach to hypothesis testing. It follows these steps, and it follows them in this order for a good reason. All hypotheses tested will go through this exact same process. The only changes are the relevant formulas to use. This template will work for all hypotheses you will ever test. 1. Set up the null and alternative hypothesis. This typically is the hardest part of the process. Here, the question being asked is reviewed. What parameter is being tested? A mean? A proportion? Differences in means? Just what are we interested in? Is this a one-tailed test or a two-tailed test? Remember, if someone is making a claim, it will always be a one-tailed test. Number 2, decide the level of confidence required for this particular case. The levels of confidence typical for social sciences are 90, 95, and 99. However, the level of confidence is a policy decision and should be based upon the risk of making a type 1 error, rejecting a good null. Always consciously consider the consequences of making a type 1 error. Next, on the basis of hypothesis and sample size, select the appropriate test statistic and find the relevant critical value, Z alpha, T alpha, etc. The critical value in a hypothesis test is the boundary line between acceptance and rejection of the hypothesis. Drawing the relevant probability distribution and making the critical value is always a big help. In this example, the confidence level is set at 95%, and so is the critical value at 1.645. Be sure to match the graph with the hypothesis, especially if it is a one-tailed test. The example here is for a one-tailed test where the null hypothesis is mu is equal to or less than mu naught. Graphically, remember that the shaded area, the alpha error, is in the tail where the greater than or less than sign in the alternative hypothesis points. In this case, it's the right-hand tail. 3. Take a sample or samples as required and calculate the relevant parameters, the mean, standard deviation, the proportion, whichever parameter you are investigating. Using the formula for the test statistic from step 2 above, now calculate the test statistic for this particular case using the parameters you have just calculated. Number 4. Compare the calculated test statistic and the critical value. Marking these on the graph will give a good visual picture of the situation. There are only two situations. A. The test statistic is in the tail. Conclusion is, cannot accept the null hypothesis because the probability that this sample mean, or proportion, came from the hypothesized distribution is too small to believe that it is the real home of these data. B. The test statistic is not in the tail. Conclusion, cannot reject the null hypothesis because the sample data are compatible with the hypothesized population parameter. Number 5. Reach a conclusion. It is best to articulate the conclusion two different ways. First, a formal statistical conclusion, such as, quote, with a 95% level of confidence, we cannot accept the null hypothesis that the population mean is equal to XXX, some units of measurement like dollars or years or miles. The second statement of the conclusion is less formal and states the action or lack of action required. If the formal conclusion was that we cannot accept the null hypothesis, then the informal one might be, the machine is broken and we need to shut it down and call for repairs. We have overthrown the status quo, and this calls for some action. We can only hope that we're not putting 25 people out of work for a month as we try to fix a perfectly good machine. But we do have some comfort. Regardless of the truth of the situation, we are 95% confident we made the right decision.